Hi students, I am continuing the chapter Complex Numbers and Quadratic Equations, and today I am going to discuss some problems related to modulus and conjugate of a complex number. So listen carefully. And this is our first question. Reduce 1 divided by 1 minus 4i minus 2 divided by 1 plus I into 3 minus 4i divided by 5 plus I to the standard form. So let's start the solution of this question. Standard form means complex number standard form a plus ib form. Okay. So given that the question is 1 divided by 1 minus 4i minus 2 divided by 1 plus I into 3 minus 4i divided by 5 plus I. Okay, so first of all I am going to do this term cross multiplication of this term, and this term remains same. Okay, so on cross multiplying this term it will become 1 plus I minus 2 into 1 minus 4i whole divided by 1 minus 4i into 1 plus I, and this term remains the same. Okay, and here the numerator, opening this bracket, it will become minus 2 into 1 will become minus 2, minus 2 into minus 4i will become positive 8i whole divided by, and also multiply the denominator term. So here it become 1 into 1 plus 1 into I plus I minus 4i into 1 minus 4i, and minus 4i into I will become minus 4i square. So this term remains the same. Okay, and in the numerator it will become 1 minus 2 is minus 1, and I plus 8i will become plus 9i whole divided by 1 plus I minus 4i will become minus 3i minus 4 into, I am going to change this I square is minus 1. We know that the value of I square is minus 1, so replacing this I square by minus 1. So in the next step it will become 9i minus 1 divided by 1 minus 3i minus 4 into minus 1 will become plus 4. Okay, do 3 minus 4i divided by 5 plus I, and this is equal to 9i minus 1 divided by 1 plus 4 is 5 minus 3i into 3 minus 4i divided by 5 plus I. Okay, so next step I am going to multiply the numerator and denominator separately. So this can be also written as 9i minus I into 3 minus 4i whole divided by 5 minus 3i into 5 plus I. Okay, so in the numerator multiplication, after multiplication it will become 9i into 3 will become 27i, 9i minus 4i will become minus 36i square, minus 1 into 3 become minus 3, minus 1 into minus 4i will become plus 4i whole divided by, and here also multiply these two complex number, it will become 5 into 5 25, 5 into I will become 5i, minus 3i into 5 will become minus 15i, minus 3i into I will become minus 3i square. In the next step I am going to replace this I square value by minus 1. So this will be equal to 27i minus 36 into replacing this minus I square by minus 1, and the remaining terms remains the same. Similarly, in the denominator, 25 plus 5i minus 15i, and here also I am replacing this I square by minus 1. So this term will become 27i minus 36 into minus 1 will become positive 36 minus 3 plus 4i divided by 25 plus 5i minus 15i minus 3 into minus 1 will become plus 3. Okay. So after rearranging, this will equal to 27i plus 4i will become 31i, and 36 minus 3 will become plus 33 whole divided by 25 plus 3 will become 28 plus 5i minus 15i will become minus 10i. Okay. And next I am going to take 2 from denominator outside, taking 2 outside from the denominator, it will become 31i plus 33 divided by 2 into 14 minus 5i. Okay. Next I am going to take conjugate of denominator. Conjugate of denominator is 14 plus 5i, right? Just changing the sign of imaginary part, so it will become 14 plus 5i is our conjugate, and multiplying and dividing the whole term by 14 plus 5i, so it will become 14 plus 5i divided by 14 plus 5i. So here taking the conjugate of denominator term and multiplying and dividing by this same conjugate of denominator. So the next step is like this, and it is equal to 31i plus 33 into 14 plus 5i divided by 2 into 14 minus 5i into 14 plus 5i. And we know that a plus b into a minus b is equal to a square minus b square. Right. So using this formula in the denominator part will become 14 square. Replacing this a by 14 and b by 5i, it will become 2 into 14 all square minus 5i all square. And the denominator I am going to multiply these two complex number. It will become 31i into 14 will become 434i plus 31i into 5i. 31i into 5i will become 155i square plus 33 into 14 will become 462. Next 33 into 5i will become 165i. Okay. So this is further equal to, here also changing the value of I square by minus 1. So our numerator will become 344i plus 155 into minus 1 plus 462 plus 165i divided by 2 into 14 square is 196 minus 5 square is 25 and I square is minus 1. Okay, and this is equal to 434i plus 165i will become 599i, and minus 155 plus 462 will become plus 307 divided by 2 into 196 minus of minus will become positive. So 196 plus 25 will become 221. Okay. So this is further equal to 307 plus 599i divided by 442. 2 into 221 equal to 442. And it can be also written as 307 divided by 442 plus 599 divided by 442i. This is in the form of a plus ib standard form. Okay. I hope you understood this question. This is our second question. If x minus iy is equal to root of a minus ib divided by c minus id, prove that x square plus y square whole square is equal to a square plus b square divided by c square plus d square. So let's start the solution of this question. Given that x minus iy is equal to root of a minus ib divided by c minus id. So let us name it as equation number 1. So next I am going to taking conjugate on both sides. It will become, conjugate means changing the sign of imaginary part. So it will become x, the minus iy imaginary part will become positive iy is equal to RHS will become a plus ib divided by c plus id. Okay, and also name it as equation number 2. Next I am going to multiply equation number 1 into equation number 2 leads to, so multiplying LHS individually and equal to multiplying RHS. Okay, so it will become x minus iy into x plus iy. That means LHS on LHS multiplying these two terms. Next term multiplying RHS term. So this will equal to root of a minus ib divided by c minus id into root of a plus ib divided by c plus id. Okay. So multiplying these terms, we know that this is in the form of a plus b into a minus b is equal to a square minus b square, right? So using this formula, LHS become, replacing this a by x and b by iy, it will become x square minus iy all square equal to, here we know that root x into root y can also be written as root xy, right? So using this property, I'm going to write together these two term using one root, and this can be equal to a minus ib into a plus ib divided by c minus id into c plus id. Okay. So on LHS it will become x square minus I square value is minus 1. So minus of minus will become positive y square. Okay. And also I am writing here taking this square inside this bracket, so it will become I square into y square and is equal to root of, this is also in the form of a plus b into a minus b equal to a square minus b square form. So this can be also written as a square minus ib all square, and the denominator also it can be written as c square minus id whole square. Okay, and we know that the value of I square is minus 1, so replacing I square by minus 1, it will become minus of minus y square here equal to root of a square minus of, here also taking this square inside this bracket, it will become I square b square, I square into b square, and the whole divided by c square minus I square into d square. On LHS it will become x square plus minus of minus will be plus y square equal to root of a square into I square value is minus 1. So minus 1, this minus will become positive. A square plus b square divided by, similarly c square minus I square value is minus 1. So minus of minus will become positive. And also write this d square. Okay. Next, I am going to squaring on both sides. This will become x square plus y square whole square is equal to squaring on RHS will cancel the root, right? So it will the answer will be a square plus b square divided by c square plus d square, right? So if you observe our question, we need to prove that x square plus y square whole square equal to a square plus b square divided by c square plus d square. So this is our final answer. So hence proved. Okay. In this question, if z1 equal to 2 minus I and z2 equal to 1 plus I, find mod z1 plus z2 plus 1 divided by z1 minus z2 plus 1. Okay, so let's start the solution of this question. Here we need given that z1 value is 2 minus I and z2 value is 1 plus I, and we need to evaluate z modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. So next I am going to replace this z1 by 2 minus I and z2 by 1 plus I in both numerator and denominator. So it will become like this. So don't forget to write this bracket here because this is a minus sign. So here the numerator will become if you observe our numerator, minus I and plus I will cancel each other, and the numerator value is 2 plus 1 plus 1, that is 4, divided by, in the denominator 2 minus I, open this bracket, it will become minus 1 minus I plus 1. And if you observe denominator, here plus 1 and minus 1 will cancel each other, and the remaining part will be 2 minus I will become minus 2I. Okay, so in the denominator part 2 is common, so taking 2 outside, it will become 2 into 1 minus I, and cancel this 2 and 4, numerator changes to 2. So this will be equal to 2 divided by 1 minus I. Okay, so here I am going to take the conjugate of denominator. So conjugate of denominator is equal to 1 plus I, and multiplying and dividing by 1 plus I from this, so it will become 1 plus I divided by 1 plus I. Okay, so inside this modulus, it will become 2 by 1 minus I into 1 plus I divided by 1 plus I, multiplying and dividing by 1 plus I. This will become like this. So it can be written as 2 modulus of 2 into 1 plus I divided by 1 minus I into 1 plus I. So this is in the form of a plus b into a minus b, and the value of a plus b into a minus b is a square minus b square, right? So next I am going to replace this denominator. Numerator remains the same, and denominator I am going to replace this a by 1 and b by I. So it will become 1 square minus I square. So it will be equal to 2 modulus of 2 into 1 plus I divided by 1 square is 1, I square is minus 1. So also this minus is there. So it will be equal to modulus of 2 into 1 plus I divided by 1 minus of minus 1 is 2. 1 plus 1, right? 2. So cancelling these 2, the final answer is modulus of 1 plus I. Modulus of 1 plus I means root of square of real part, that is 1 square, plus square of imaginary part. So coefficient of I is 1, so again 1 square. So the answer will be 1 plus 1 is 2. So root 2 is our final answer. Okay, I hope you understood this question. So just replacing this Z1 by 2 minus I and Z2 by 1 plus I in this question, we will get our final answer as root 2. Okay, is it clear? This is our next question. If a plus ib is equal to x plus I all square divided by 2x square plus 1, prove that a square plus b square equal to x square plus 1 all square divided by 2x plus 1 whole square. Okay, so let's start the solution of this question. Given that a plus ib is equal to x plus I all square divided by 2x square plus 1. So let it name it as equation number 1. Okay, next I am going to taking conjugate on both sides. On both sides, the next step will be a minus ib is equal to x plus I, the conjugate is x minus I, and also write this whole square. Here in the denominator it's full of real parts, so does not change if we take the conjugate, because if we take a conjugate value, the sign of imaginary part are changed, right? So here in the denominator it does not contain any I part, that means imaginary part, so this term remains the same, and let us name it as equation number 2. Okay, next I am going to multiply 1 into 2, so it will become the LHS part, it will be equal to a plus ib into a minus ib. It is equal to, on RHS part, it is equal to x plus I all square into x minus I all square divided by 2x square plus 1 into 2x square plus 1. Okay, and this is in the form of a plus b into a minus b, and the answer will be a square minus b square, right? Using this formula on RHS, it will be equal to a square minus ib all square is equal to, and here also taking this square common, so it will become x plus I into x minus I, taking this square as common, and divided by the denominator will become 2x square plus 1 whole square. Okay, so here on LHS, a square minus, taking this square to inside this bracket, it will become I square into b square equal to, here also this is as same as that of this formula, like a plus b into a minus b. Replacing this a by x and b by I, the formula is equal to, will changes to x square minus I square, and also write this square here, divided by 2x square plus 1. And we know that the value of I square is minus 1. So I am going to replace this I square by minus 1. Okay, equal to, here also x square minus of minus 1, I square value is minus 1, whole square divided by 2x square plus 1 whole square. Okay, and the LHS will become a square, minus of minus will become positive, a square plus b square is equal to x square minus of minus will become plus 1 whole square divided by 2x plus 1 whole square. Okay, if you observe our question, we need to prove that a square plus b square equal to x square plus 1 whole square divided by 2x plus 1 whole square. So now we have proved. Okay, so hence proved. Okay, I hope you understood this question. This is our next question. Let Z1 equal to 2 minus I and Z2 equal to minus 2 plus I. Find, first part of the question is real part of Z1 Z2 divided by mod Z1, and second part of this question is imaginary part of 1 divided by Z1 into Z1 bar. Okay, so let's start the solution of this question. Okay, so given that Z1 equal to 2 minus I and Z2 equal to minus 2 plus I. So first of all we need to find out Z1 into Z2. Okay, so Z1 into Z2 is equal to 2 minus I into minus 2 plus I. So multiplying these two complex number, the answer will be 2 into minus 2 will become minus 4, 2 into plus I will become plus 2I, minus I into minus 2 become plus 2I, and minus I into plus I will become minus I square, and this will be equal to minus 4 plus 2I plus 2I, replacing this I square by minus 1, and the answer will be minus 4. Minus of minus 1 will become plus 1. So minus 4 plus 1 leads to minus 3, plus 2I will become 4I. Okay, and next we need to find out Z1 bar. So Z1 is 2 plus I. So Z1 bar means conjugate of Z1 is replacing this sign of imaginary part changes, so it will become 2 plus I. Okay, so next I am going to find out Z1 Z2 by Z1 bar is equal to, replacing this Z1 Z2 by minus 3 plus 4I divided by Z1 bar value is 2 plus I. Okay, so taking conjugate of denominator and multiplying and dividing with this fact, this step, so it will become 2 minus I divided by 2 minus I. Okay, conjugate of denominator is 2 minus I, and multiplying and dividing with this question. So it will become minus 3 plus 4I into 2 minus I divided by 2 plus I into 2 minus I. Okay, so again multiplying these two complex number, this will be equal to minus 3 into 2 will become minus 6, minus 3 into minus I will become plus 3I, 4I into 2 will become plus 8I, 4I into minus I will become minus 4I square, whole divided by, this is in the form of a plus b into a minus b, which is equal to a square minus b square. Applying this formula here, replacing this a by 2 and b by I, the formula will become 2 square minus I square. Okay, so next step will be minus 6 plus 3i plus 8i will become 11i minus 4 into value of I square is minus 1 divided by 2 square is 4 minus of I square value is minus 1. So this will be equal to minus 6 plus 11i minus of minus plus 4 divided by 4 plus 1, and this will be equal to minus 6 plus 4 will become minus 2 plus 11i divided by 4 plus 1 is 5, and this can be also written as minus 2 by 5 plus 11 by 5i. This is our real part and this is our imaginary part. So in this question, first part of the question, we need to find out real part of z1 z2 by z1 bar. So from this we get real part of z1 z2 by z1 bar is equal to minus 2 by 5. Okay. Second part of the question, we need to find out imaginary part of 1 divided by z1 bar, z1 into z1 bar. So we need to find out first z1 into z1 bar. Our z1 is 2 minus i. 2 minus I into z1 bar is 2 plus I. Okay. So z1 into z1 bar is equal to, this is in the form of a plus b into a minus b. So this will be equal to a square minus b square. So replacing this a by 2 and b by I, it will become 2 square minus I square equal to 4 minus of minus 1. Value of I square is minus 1, or equal to 4 plus 1 equal to 5. The value of z1 into z1 bar is equal to 5. Okay. So I am going to introduce a new formula here. z1 into z1 bar is equal to mod z into z bar is equal to mod z square. Also let us check it once. If we need to find out z into z bar here, so given that 2 minus I into 2 plus I is our z into z bar, so we need to find out mod z. Mod z is equal to root of real part of z, right? So real part of z is 2 square and imaginary part of z is our z is 2 minus I. Okay. So real part of z is 2, so 2 square plus imaginary part of z is minus 1 square. So it will become 2 square. 4 plus minus 1 square is 1. Mod z equal to root 5. So mod z all square is equal to root 5 square equal to 5. So this is same as that of this answer. So this is a important formula. Z into z bar is equal to mod z square. Okay. So in this question we need to find out 1 divided by z1 bar. So 1 divided by z1 into z1 bar is equal to 1 divided by 5. The value of z1 into z1 bar is 5, right? So replacing this z1 into z1 bar here, we get 1 by 5. Okay. So this can be also written as in standard form 1 by 5 plus 0i. Okay. Our question, we need to find out imaginary part of 1 divided by z1 into z1 bar. So if you observe our answer of 1 divided by z1 into z1 bar, imaginary part is 0, right? So the value is 0. Okay. I hope you understood this question. Find the modulus of 1 plus 2i divided by 1 minus 3i. Okay. So we need to find out modulus of 1 plus 2i divided by 1 minus 3i. One of the property of modulus is mod Z1 by mod Z1 by Z2 can also be written as mod Z1 divided by mod Z2, right? So using this property here, this can be also written as mod 1 plus 2i divided by mod 1 minus 3i. Okay, so calculate modulus separately. So in the numerator it will become root of square of real part is 1 square plus square of imaginary part, that is 2 square, divided by square of real part, root of square of real part, that is 1 square here, and plus square of imaginary part minus 3 here, and it will be equal to root of 1 plus 4 divided by root of 1 plus 9. Okay, and it will be equal to root 5 divided by root 10. Okay, and one of the property of root is root of x by y can also be written as root x by root y. So using this format, it can be written as root of 5 by 10. So cancelling these 5 and 10, so the denominator will become 2. So root of 1 by 2, or it can be written as 1 by root 2. So this is our final answer. Okay, so this is a very simple question. This is our next question. Find the real numbers x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 minus 24i. Okay, so in this question we need to find out x and y. These x and y. So given that x minus iy into 3 plus 5y is equal to conjugate of this number. So if z equal to minus 6 minus 24i, the conjugate of this number will be minus 6. Changing the sign of imaginary part, it will become plus 24i. Okay, so I am writing here minus 6 plus 24i. Okay, so next I am going to multiply these two complex numbers. So it will become x into 3 will become 3x, x into 5y will become plus 5xi, minus iy into 3 will become minus 3yi, minus iy into 5y will become minus 5yi square equal to minus 6 plus 24i. Okay, so here changing the value of I square as minus 1 here, so it will become 3x plus 5xi minus 3yi, minus of minus will become plus 5y equal to minus 6 plus 24i. Okay, so next I am going to write the real part together. So here 3x and plus 5y are real part, and imaginary part, writing the imaginary part together, here we get I into 5x minus 3y. The imaginary part is equal to minus 6 plus 24i. Okay, so equating two complex number, if a plus ib is equal to c plus id, so we can write as a equal to c or b equal to d. Similarly, given that the multiplication of these two complex number is equal to conjugate of this number, so we can write as the real part equating real part and imaginary part on LHS and RHS, we get 3x plus 5y, real part on LHS is equal to real part on RHS, that is minus 6 here, and again the imaginary part of LHS is 5x minus 3y equal to imaginary part of RHS, that is 24. Okay, so let us name it as equation number 1 and equation number 2. So I am going to find out the value of x and y. So here we can write it as 3x plus 5y equal to minus 6. That is our equation number 1. And changing this, writing this second equation as 5x minus 3y equal to 24 here. Okay, so I'm going to multiply equation number 1 throughout by 5. It will become 5 into 3, 15x plus 5 into 5, 25y is equal to 5 into 6, minus 30. Okay, and again equation number 2, I'm going to multiply equation number 2 with 3. So it will become 3 into 5, 15x minus 3 into 3y, 9y equal to 24 into 3. Okay, so 24 into 3 means 72. So let us name it as equation number 3 and equation number 4. Okay, next I am going to subtract equation number 3 and 4. It will become 0. 25y minus of minus, so subtracting here changes the sign full negative, so 15x minus 15x will leads to 0, and 25 minus minus will become positive. 25 plus 9 will become 34y equal to minus 30 minus 72. So minus 30 minus 72 will become adding 72 and 30 will become 2 and 102, and the sign is minus, so minus 102. So here y is equal to minus 102 divided by 34 is equal to minus 3. Okay, next I am going to substitute the value of y in equation number 1. So our equation number 1 is 3x plus 5y equal to minus 6. So substituting the value of y in equation number 1, so it will become 3x plus 5 into minus 3 equal to minus 6. So this implies 3x minus 15 equal to minus 6. 3x equal to minus 6 plus 15 equal to 9. So from this we get 3x equal to 9, x equal to 3. So the value of x and y are x equal to 3 and y equal to minus 3. Okay, I hope you understood this question.